Hello students, now let us see the electron gain enthalpy. Okay, the meaning of electron gain enthalpy and it's trained in the group and period. So what is electron gain enthalpy, student? You see here with the help of electron affinity or electron gain enthalpy, that is the both are the same terms, students, for defining the energy released when an extra electron is added. So what is the definition, student? It is defined as the amount of energy released. It is defined as the amount of energy released when one extra electron is added to neutral isolated gaseous atom. Okay, so whenever you are adding the one electron, extra electron, to the neutral isolated gaseous atom, so that is whatever the energy released, that is what is known as, student, that is electron gain enthalpy. So here the terms you try to understand. It is defined as the amount of energy released when one extra electron is added to neutral isolated gaseous atom. What is meaning of this, student? One VR atom is having, this is the either you consider any metal, you consider, that will be helpful to understand. What is meaning of this, student? One atom metal is there. Okay, this metal should be isolated means it will be the single atom, and that should be in the gaseous form. And when you are adding the one extra electron, so it will be added here. So what will be happening, student? What their terms they are using, that is the metal, that is what will happen here, that is metal anion will form in the form of gaseous ion, and the same time, that is energy is released, energy released. Of this energy released, student, this energy released is known as electron gain enthalpy. This is what is known as electron gain enthalpy. Okay, this is the electron gain enthalpy. So the electron gain enthalpy is the simple terms, student. The when the addition of electron is taking place, the energy is released, that is known as electron gain enthalpy. Now let us try to understand another term. If more energy is released in the process, the higher is the electron affinity. Okay, the more energy release, higher will be the electron gain enthalpy or electron affinity. Electron affinity is the reverse of ionization energy, that is the minus E1 is termed the first electron affinity as it involving addition of one electron. Second electron affinity of an element is defined as the amount of energy required to add one electron to its mononegative ions to convert into the M2 minus ion. Now student, this line I am explaining, this paragraph, this is the Narayana Need book, paragraph from Narayana Need book. So what is meaning of this line, student? They are saying when you are adding, that is already negative charge is there. Okay, if negative charge is there, student, and if you want to add one more electron, if you want to add more electron, so repulsion will be there. So that is that will be the you need to M2 minus plus wherever the energy is there, energy supplied, where energy, what is that, student? Energy, it is not releasing energy we have to supply. So that will be the negative sign of the energy. What is meaning of this, student? What is meaning of this? Here you come out, that is when you are adding second electron affinity, here is there what the terms they are using, that is in case of the second electron affinity of an element is defined as the amount of energy required for the second electron. If you are adding the second electron, you need to add, you need to supply the energy, add one more electron to its mononegative anion to convert into M2 minus dinegative. Okay, let us see in the how it is varying in the group and period. As we move across the period from left to right, since the electron being added in the same subcell, nuclear attraction increases, the size decreases, hence the electron affinity increases. So more the attraction, they are saying, student, more the attraction, more is the energy released. Okay, more attraction, more the energy released. Okay, that is why in the period it is increasing. Again you read out, as we move across the period from left to right, since the electron being added in the same subcell, nuclear attraction increases, size decreases, hence electron affinity, what will happen, student? Electron affinity will also increase. Now in the group, down the group, electrons get added in the new subcell. Down the group, electron added in the new subcell. Hence the size of atom increases. Okay, size of atom increases. The nuclear attraction decreases. And if the nuclear attraction decreases, hence electron affinity, what will happen, student? Electron affinity decreases. And electron affinity value is expressed in the kilojoule per mole. Student, wait, no, that. Hello student, the same electron gain enthalpy, let us read out from the NCERT book. This is from the NCERT. Okay, for the better understanding, we are considering two books for the understanding. Okay, when an electron is added to a neutral gaseous atom, suppose X, to convert into the negative ions, the enthalpy change accompanying that the process is defined as the electron gain enthalpy. Okay, electron gain enthalpy provides a measure of the ease with which an atom adds an electron to form an anion, as represented by the equation 3.3. So means how the easy the electron will be added to a neutral isolated gaseous atom. Till now the definition is not given here. Let us see. That is, one is isolated gaseous atom is there. You are adding one electron. It is converting into anion. Depending on the element, the process of addition of an electron to the atom can be either endothermic or exothermic. Anything is possible, student. It can be endothermic or exothermic. Okay. Now, second point is see. For many elements, energy is released when an electron is added to the atom and the electron gain enthalpy is negative. For example, group 17 element, the halogens, have very high negative electron gain enthalpy because they can attain the stable noble gas electronic configuration by picking off an electron. On the other hand, noble gas have what is, student, larger positive electron gain enthalpy because the electron has to enter in the next higher energy principal quantum number, leading to a very unstable electronic configuration. It may be noted that electron gain enthalpy have larger negative value towards the upper right of the periodic table, preceding the noble gas. What is meaning of this, student? Let us try to understand that. They are saying that is, if you are talking about halogen, FClBri. Okay, so that is, they are saying if you are adding one electron, one electron. So what is they are saying? They are attaining that is stable configuration. So it's stable configuration if they are attaining, that is they are saying configuration. So that is high, that is high electron gain enthalpy. No, it is the high electron gain enthalpy. This is having the high electron gain enthalpy. But in case of, they are saying if you are taking helium, neon and argon, so in this case they have the stable configuration, So they are saying that is difficult to add electron, difficult to add electron. If you are adding the electron, difficult to add electron, and difficult to add electron means positive electron gain enthalpy, or you say positive electron gain enthalpy. Generally it is supposed to be a 0. Electron gain enthalpy is 0. Now let us read out the other statement. The variation of electron gain enthalpy of element is less systematic than the ionization enthalpy. As general rule, electron gain enthalpy become more negative with increase in the atomic number across a period. The effective nuclear charge increases from left to right across a period. Consequently, it will be easier to add electron to the smaller atom, since the added electron on the average would be closer to the positively charged nucleus. Okay, we should also expect the electron gain enthalpy to become less negative as we go down the group, because the size of the atom increases and the added electron would be far from the nucleus. This generally in the case of 3.7, table 3.7 we will read out how electron gain enthalpy oxygen fluorine is less negative than that of the succeeding element. This is because when an electron is added to oxygen or fluorine, the added electron goes to the smaller n-2, okay, quantum level. it suffered this significant repulsion from the other electron present in the level for the n equal to 3 quantum level. The added electron occupy a larger region of space and electron repulsion will be much less. So they are saying, if you are talking about the student, I am explaining here again what is meaning of this line, student. Here you try to understand. Okay, now it is okay, it's getting erased. Okay, what is meaning of that paragraph, student? They are saying that is, suppose we are having the fluorine and chlorine. This becomes to n equal to 2 and n equal to 3. So here is the difficult, student, difficult to add electron, but here is the easy to add electron, region they have written here, student, that is here is oxygen or fluorine is less negative than that of the succeeding element. This is because, here is writing, this is because when electron is added to oxygen fluorine, the added electron goes to smaller n equal to 2 quantum level and suffers significant repulsion from the other electron, more repulsion present in this level. For example, n equal to 3 quantum number, that is the added electron occupy a larger region of space, electron repulsion is less. So less repulsion is there, student. Ag electron as less repulsion, it is the less repulsion is there. If it is less repulsion, student, that is more energy release, more electron gain enthalpy, more electron gain enthalpy, okay. Less repulsion means more electron gain enthalpy. Here you see, student, in the table what they are saying, electron gain enthalpy they have given in kilojoule per mole. Hydrogen is minus 73, lithium is minus 6, and here is sodium is minus 53. So here is the decreasing order is there. But here if you see, student, group this one, oxygen sulfur, so you will find that is, here is the increase is there, little increase is there. This is the increasing order is there for oxygen and sodium, oxygen, sulfur, selenium, tellurium, and that is, if you talk about the this one. So what is meaning of this, student? What is meaning of this? If you talk about the group 16 element and group 17 element, so group fluorine, if you group 17 together you try to, here if you are going down the group, student, going down the group, so what is happening? So down the group is decreasing, down the group it is 200, 195, 190, it is the decreasing order, this is decreasing, but when the first two element you see, student, first two element increases, the region is same, student, oxygen and sulfur. Oxygen is smaller size, addition is difficult, and fluorine is smaller size, addition is difficult. So addition is difficult, so less electron gain enthalpy, and addition is easy, so more electron gain enthalpy. And here is the this one, they are supposed to be almost, they are the zero, student. For the noble gases, this is almost zero, student. So you try to understand, student. We will solve some more problem on the basis of these, students. Thank you so much for watching, friends.